Derive an expression for the centripetal force acting on a particle of mass m moving with velocity v in a circle of radius r. Now, this problem we have is a problem under dimension analysis, where we are looking at how to derive an expression, or rather an equation or formula. So for this case, we are supposed to use dimensional analysis. Now, in order for us to be able to derive an equation, we should base the derivation on an assumption that the equation is dimensionally homogeneous, meaning that left hand side is automatically the same as right hand side. And for that means that we'll not have issues. So this which we've been given is a statement. And physics being mathematics, it is very important that we change this into an expression. By this I mean an equation. So what we'll do is we'll look at the data we've been given and see how we can present it mathematically. So we've been given centripetal force. The centripetal force is the one acting on a particle of mass moving with velocity v in a circle of radius r. So this force we have is centripetal force, a force exerted on objects moving in a circular path. Now, looking at this, it means that force is dependent on the mass, the velocity, and the radius, which will mean that as an equation, force is going to be on the left hand side. Now, depending in mathematics is used, or rather is represented by this symbol, which means variation. So F is dependent on mass, velocity, and the radius, meaning that F is direct proportional to the mass, the velocity, and the radius. So we've taken our first step in coming up with a mathematical representation of this statement. Now we have the quantities on the right, which are mass, velocity, and radius. Now we don't know if these are repeating themselves. By this I mean they have exponents. So to do this, since we don't know, the exponents are going to be presented as variables, and in this case we'll assign letters A, B, and C. So we're assigning these letters which we don't know to mean the powers. So here our task will be on finding A, B, and C. But now it is very important that we change this symbol to an equal sign. Now changing it to an equal sign comes with a constant k. So we'll have it as k times m to the power a, v to the power b, and the radius to the power c. Okay. So to use dimension analysis, we need to understand to say k being a constant is to be ignored. So we'll have our expression as f equal to m to the power a, v to the power b, r to the power c. Now let's assign dimensions for each. So the assumption is that for us to be able to derive, it means that we know the dimensions of each physical quantity. So for force, we need to understand, say the dimensions are m, l, t to the power negative 2, which is equal to m is the mass, and it is raised to the power a, okay, multiplied by v is length times t to the power negative 1, which is raised to the power of b. Then we're multiplying with radius. So radius is the distance from the center to the circumference of the circle. So since here is a circular path, I mean that we definitely have radius. And radius is length, which is having L as its dimension, raised to the power c, so which I can just indicate inside here, since I'm only doing one physical quantity there. So left hand side is equal to right hand side. Okay, so this is my left. I'm saying equal to m to the power a. Now I will distribute b inside the second bracket. I'll get l to the power b, t to the power negative b, and then I'm multiplying with the l to the power c. Alright, so from here, I'll write my left hand side to be equal to, so I have m to the power a. If I look at this, I have l repeating twice, so I'll add the powers for l, which are b and c. Then I have t to the power negative b. So you need to understand to say, according to exponential equations, if there are two parts and the bases are the same, it means that the powers so we're going to set the powers to be the same since the bases are the same. So for m, I have a 1 here, and for m there I have a. So it means that my a is equals to 1. Let me write this properly. My a is equals to 1. Then the second part is b plus c, which is for l on the right, and on the left I have 1. So it will be b plus c being equals to 1. And lastly, I have negative b. Negative b is equals to negative 2. Now since there are negatives both sides, I'll just cancel and I'll get b to be 2. So from here I know a and b. Let me find c. So from this second expression, which is b plus c equals to 1, I'll make c subject, so it will be c is equals to 1 minus b. And since I know b to be 2, so it means that I have my c to be 1 minus 2, and this gives me negative 1. So I have that a is equals to 1, b is equals to 2, and c is equal to negative 1. Now from here, I'll go back to my equation, which is f equal to k, m to the power a, v to the power b, r to the power c. Then what I'm now going to do is, where there's a, I'll substitute. So I'll write my k, I have my a, my m, a, I'll substitute with the 1, then v, substitute with the 2, then r, I'll substitute with the negative 1. So we understand, say, a base to the power 1 is that same base, so I have my f equals to k, m, v to the power 2. Now r having a negative exponent will just come down here, and the power automatically becomes a positive 1, which is just our value r without a power. Now we understand to say dimension analysis has limitations in that it can't provide us with the constants. So we need to use another method to know what the constant is. So constants can be determined by using different scientific methods, which are some being experimentation, and we can also use the concept of memorization to determine what k is. So from this, you need to understand, say, our k, just for this case, is 1. So our constant is 1. So that my force is equal to mv squared over r. And this is my equation. Please subscribe to our YouTube channel for more interesting science content. See you in the next video.